warm good afternoon to all the participants and faculty members who are viewing this webinar series. Today we have Mr. Sachdev Vyas, sir, Electrical and Instrumentation of Birla Corporation Limited area, Rajasthan unit. So I welcome Sachdev Vyas sir for a valuable session of his on the VFD drives. He's having a vast experience of 34 plus years in the industry. So all the participants, you can acquire a lot of knowledge from him. And at the end of the session, you can put up all kinds of queries, whatever you are having, so that he can be answerable for all of us. So with this, I would like to hand over the entire session to the Vyas sir. Sir, you can have your session today for us.
Okay, thank you.
So you can continue your session, sir, by sharing this.
Good afternoon, everyone. Today I will discuss about variable frequency drive. What is variable frequency drive? Where we use it? What are the limitations? What are the pros and cons of using VFD? What are the adverse effect motor have when connected to VFD? We will discuss about it. So we will discuss about basics of motor, why VFD is required, power devices used in VFD, rectifier section, inverter section, what is pulse width modulation, what is some features of power loss ride through, open closed loop, MB drive technology, what is the scalar and vector control, what is harmonics, and how this VFD generates harmonics in the power network. Why we use VFD for power saving? What is the power factor when we use motor with VFD? Operational some concerns, snubber circuit and parameterization, and do's and don'ts. Continue. So first of all, we must know all about the motor. That VFD is generally used with the squirrel cage induction motor. This is the constructional view of squirrel cage induction motor. Major part of squirrel cage induction motor is the rotor and stator. When stator is energized with three-phase AC supply, the flux is generated in the air gap. This air gap gets linked with the rotor conductor and EMF is induced in the rotor conductor. As you all know, the rotor of the squirrel cage induction motor is short circuited at the end ring. That's why current starts flowing in the rotor. Due to interaction of the flux generated in the air gap and the current flowing in the rotor circuit, due to this interaction of the interaction of two quantities, torque is produced in the motor. What type of field is produced in the motor? That is rotating type. One is revolving type, one is rotating type. In single phase motor, you cannot rotate the motor with only supplying the single phase supply. It is because it generates revolving field. For rotating of the single phase motor, we use one more winding with use of capacitor. 90-degree phase shift is given so that motor can be self-started. But three-phase induction motor is self-started motor because the three-phase produce rotating magnetic field in the air gap. If you have any question, you can ask in between the session, please. Rotating magnetic field. What is the speed of rotating magnetic field? Speed of rotating magnetic field is known as the synchronous speed of the motor. That is Ns is equal to 120 into frequency divided by number of poles. So for 4-pole motor, Synchronous speed is 1500 rpm. For two-pole motor, it is 3000 rpm. What is the slip? Slip is the basically difference between the rotor, the speed at which rotor is rotating with respect to the synchronous speed of the motor. Difference between this is known as the slip. Slip is depend upon driving equipment torque also. Higher the torque, slip will be more. Next. Okay. What is torque? Torque is the turning ability of the motor, and torque depends upon the, as I said earlier, it depends upon the two parameter, flux in the air gap and the rotor conductor, that is I2 cos phi. So torque is proportional to the flux and rotor current. In other words, we can say torque is proportional to V square. Why? Because flux is dependent upon V and I2, rotor current is also dependent on V. So torque is proportional to V square. Rotor conductor has definite resistance. When current flow through it, the power loss occurs in the rotor, that is equal to I2 square R. And mechanical power output is I2 square R2 1 minus S by S. This is mathematical formula. We will discuss in detail later. This is the speed torque curve of the induction motor. In starting torque of the induction motor is low. Then as motor accelerates, it goes up to max torque. Then according to load line of the driven equipment, it set its point at that point. This point, when this is negative slope, this is the unstable region. Motor can be stable between the max torque to this point. This is the stable region where motor can establish its speed. At start, motor takes high current and produce very low pull-up torque. As speed increase, torque is increased. At full speed, it can deliver the full torque and stator current is reduced.
Yes, sir. You are sharing anything?
Yeah?
You are sharing anything? आप कुछ शेयर कर रहे हैं क्या? स्क्रीन शेयर?
आपको आपको दिख रही क्या?
नहीं, आप कुछ स्क्रीन शेयर कर रहे हैं ना सर?
हाँ, स्क्रीन शेयर कर रहे हैं.
लेकिन वो नहीं दिख रहे सर. आप एक बार चेक करना. प्रेजेंट नाउ में जाना.
इंडायरेक्ट स्क्रीन.
ओके. और योर एंटायर स्क्रीन ऐसे करना.
या एंटायर स्क्रीन सिलेक्टेड.
हाँ, आपका एंटायर स्क्रीन सेलेक्ट करेगा तो फिर वहां पे आपको उस पर क्लिक करके सेलेक्ट करना. यस. हाँ, ओके, परफेक्ट. Yes, sir. It is visible. You can present.
Star delta starter. One is dual starter, and this is GRR starter. GRR starter is used for slip ring induction motor only. soft starter, and the VFD. VFD is starter for soft starting and soft stopping the motor, and it can control the speed of the motor from 0 to base speed of the motor. Yeah, स्पीकर नहीं चल रहा, वॉल्यूम चल रहा है, कुछ क्वेश्चन पूछा था अभी. हेलो,
Yes, sir.
कोई क्वेश्चन रेज किया था किसी ने?
Sir?
क्वेश्चन रेज किया किसी ने?
नहीं नहीं, कोई क्वेश्चन नहीं सर. क्वेश्चन लास्ट पे आपको आएगा सर.
ओके ओके ओके
या
ओके.
या
Yeah. So VF drive is used for speed control of the motor as well as for soft starting and stopping of the motor. Whereas soft starter is used for soft starting and soft stopping of the motor. We cannot control the speed of the motor by soft starter. Before selecting a motor for particular application, it should be known that which type of load we are going to drive with the motor. So first is the constant torque. Some of the application demands constant torque throughout its speed range. Variable torque at lesser speed, the torque demanded is low, and as the speed is increased, the torque requirement increase. This type of load is known as variable torque. Like centrifugal fan, pumps, all this type of load comes into this category. These are the type of loads and torque demanded by the equipment. Induction motor can be used in 4 quadrant, and this is known as the 4 quadrant operation. First quadrant and third quadrant is for driving, whether you can drive the motor in clockwise direction or anti-clockwise direction. And second and fourth quadrant is the braking. You can drive the motor in clockwise direction, then you can brake it. We can rotate in opposite direction, then we can brake it. It is used in plane application. What is braking? When there is any application which demands immediate stopping of the motor after supply is switched off, then this type of braking, different braking methods are used. One is the dynamic braking. Dynamic braking are of 2 types, rheostat braking and DC injection braking. Second is the regenerative braking. Third is the plugging. Plugging means supply is reversed. Two phase supply is reversed, then motor start operating in the reverse direction. So as far as VFD is concerned, we will discuss about the regenerative braking. Regeneration in AC drive. So I will take this slide later on. When motor is operating in motoring zone, its slip is between 1 and 0, positive. When motor is operating in generating region, its slip is in negative. And when you are using this motor in braking zone, the slip is greater than 1. This is example of DC motor. When after motor is stopped, the energy stored in the winding get dissipated through the braking register and motor immediately stops. This is called the rheostic braking. Dynamic braking in VFD. Basically, in VFD, there are two sections. One is the converter section or rectifier section, and second one is the DC bus, capacitors, then inverter. First, AC is converted into DC. Then DC is again converted into AC for driving the motor. In between the link, there is one IGBT and regeneration register. External supply, external motor starts operating at not at 800 rpm. It may be at 825 rpm or 850 rpm. Its speed will increase. In that condition, what will happen? Your actual rotor position, rotor speed is more than the synchronous speed. In this condition, the motor will start feeding the energy to capacitor bank through the IGBT inverter. So, to dissipate that energy, to bring down the speed of the motor from 840 or 850 to 800 again at set point, what happens? This DC bus voltage is sensed by the IGBT control circuit, and if VDC is greater than V set point, suppose its DC link voltage is 600, it should be maintained at 600, and if motor is feeding the energy and voltage increase up to 650, then what will happen? The controller will issue the command to IGBT. IGBT will start conducting, and that energy, that regenerative energy will be get dissipated in the register. This is the dynamic braking of the motor through VFD. One is DC injection method. DC injection, what happens? When there is stored energy in motor, when after switching of the motor is rotating, but we need to stop it immediately. Then we can inject the DC supply in the stator of the motor. What will happen? That DC supply will generate flux in the air core. Flux in the air core, as the rotor is rotating and magnetic flux is generated by DC, then what will happen? The flux gets linked to the rotor and the energy will be dissipated in the rotor circuit. VFD is popularly used for power saving. We can use GRR in slip ring motors for power saving and speed control. But in GRR, you have limitation of speed control. Second, energy loss take place in the GRR resistance. If input power to motor is PI, then output power will be PI minus power loss. Power loss in the motor. And power loss is equal to SPI. So output power will be input power minus lossage. So input power is PI, power loss is SPI. Then mechanical output power will be 1 minus S into PI. In case of VFD, power loss SPI is very less. Some of the power devices we use in VFD is first we discussed about converter or rectifier section which converts 3-phase AC into DC. For this, power diodes are used. Even in modern VFD, IGBT is also used for rectification purpose. As you all know, diode is used in the rectifier section in the full wave control, 3-phase control. But this is uncontrolled rectifier. Whatever input we give AC, it will be converted into DC. This is the P-type PN junction. This is a depletion layer. And if you see the diode, this is the anode, cathode, a stripe marks cathode. Working principle of power diodes: when power diode is forward biased means the applied voltage should be more than 0.7 for silicon diode. Why 0.7? 0.7 is the depletion region voltage or cut-in voltage of the diode. So always, if you want to make the diode forward biased, the anode should be more positive with respect to cathode and its magnitude should be more than 0.7. So here, this anode P region is connected to plus and N region is connected to minus. So this plus battery, it will push the holes in the P region to N region and current starts flowing. This is IGBT. IGBT is basically used in inverter section. First, BJT was developed, bipolar junction transistor. Then FET were introduced. Then JFET. Then MOSFET, and this IGBT. And later stage IGCT also. But in VFD we use IGBTs. IGBT is used in inverter section as a switch. Its function is to on or off. So some of the features of IGBT is you can switch it or switch on very fast. There is very low switching losses. Easy to turn on, easy to turn off, and very fast switching speed. हाइड करो ये नीचे आ रहा हाइड स्क्रीन तो दिखेगी so you can see a static VI characteristic and switching characteristics of the IGBT. It's easy to turn on, easy to turn off. TF turn off time is very less compared to BJT. Turn on time is also very less as compared to BJT. This is the testing methods of IGBT used in VF drive. This is the inverter section. 6 IGBTs are used. In inverter section, this IGBT can checked with the multimeter. For forward, as you check BJT with multimeter, similarly, with same method, we can use the IGBTs. Why speed control is required? Speed control of motor is required for a soft starting of the motor as per process requirement. In some process, speed is required to vary according to process. So speed control is required, and speed control is again coupled with the power saving in some cases. If we are using soft starter, the motor will start very smoothly without any jerk, and we can stop the motor very smoothly. Thus, it increases the life of the motor, life of the driven equipment, and also reduce the stress on the electrical network. But this soft starter can't be used for speed regulation or speed control. Only starting and stopping of the motor without any jerk. You can see if I start the motor on DOL, it takes about 600% current. In case of star delta starter or soft starter, even 250%, even 200. So drastically, in rush starting current can be reduced by use of starter. Necessity of speed control of motor by power factor. What is power factor? Power factor is nothing but the real power divided by the apparent power. Here, when we use VFD, when the load is linear, suppose resistive load, then simple formula power factor is kilowatt upon kVA is true. But if we are using VFD or any other electronic equipment which generates harmonics in the power network, in that condition we'll have to calculate the distortion power factor of the system. In that condition, total power factor or so-called true power factor of the system will be displacement power factor multiplied by distortion power factor. So when we use VFD, SPRS system or DC drive, all these electronic equipments are non-linear devices. Non-linear devices means these devices draw the non-linear current if we apply the sinusoidal voltage, or if we increase the voltage linearly, the current will not increase in linear proportion. That is called the non-linear devices. So all electronic equipment, diode, transistor, Zener diode, JFET, FET, MOSFET, IGBT, IGCT, UJT, all electronic components are non-linear devices. Sometimes it is power factor in case of VFD is generally confused by fundamental power factor. Actually, drive when diode is conducting, its fundamental power factor means voltage and current are in phase. So fundamental power factor of system is 1. When you are using VFD, fundamental power factor is 1. But overall power factor, if you will see, will come around 0.97 or 98. This is due to this lower power factor. 1 to 0.97 is because of the distortion power factor. So speed control, we know synchronous speed is 120 F upon P, where slip is difference between the synchronous speed and the speed of the rotor. So actual speed of the rotor is equal to synchronous speed 1 minus S. If we see this formula, the actual speed of the rotor can be varied by changing the frequency, by changing the poles, or changing the slip. By changing the pole, we can decrease the speed or increase the speed in synchronous speed of the motor. Suppose 3000 RPM motor, you can reduce the speed 3000 to 1500 RPM or 1000 RPM or 750 RPM. you can get the discrete, not continuous speed regulation can't be achieved by pole changing method. Only we can achieve the discrete speeds. It is generally used in the workshop by pole changing method, and in the industry it is not used. Second one is by changing the slip. By changing the slips means slip can be changed by inserting resistance in the rotor circuit, and it is possible if your motor is slip ring motor. Three-phase slip ring motor, you can connect external resistance. By varying the resistance, you can control the slip of the motor, and we can govern the speed of the motor. But in the industries nowadays, most of the motors are squirrel cage induction motor. We are not using the slip ring induction motor because of its maintenance. Maintenance means you need to check the carbon brushes, carbon assembly, slip ring periodically. In case of squirrel cage motor, it is robust and there is no need of maintenance. Third one is squirrel cage induction motor. This frequency control. Frequency control by changing the frequency. By changing the frequency, we can make the squirrel cage induction motor as a multiple synchronous motor. I can make it 1 hertz synchronous motor, 2 hertz synchronous motor, or 3, 4, 5, 6. This way I can achieve the speed control from zero speed to base speed of the motor. This is the example of slip control method which industry use in slip power recovery system. This system is used where speed range between 60 to 100% is required. Below this, the drive is run on the LRS, and after achieving 60% speed, the LRS is changed over from LRS system to SPRS system. After that, 60 to 100% speed can be varied, but it is applicable only when you use slip ring induction motor. Now coming to VFD, this is the block diagram of VF drive. First is the input section is the converter. Three-phase AC supply is given to input converter. In converter there is 6 diodes which acts as a full wave rectifier, and its output is DC. In DC circuit there is a large bank of electrolytic capacitors. It is used to filter out the AC component or smoothens the DC. Then this DC voltage is converted into AC voltage by the inverter section. Here you can see these are the ripples, and after filtering this is pure DC. Then this is converted into AC. Again, inverter output voltage will be like this: positive, negative. When it's interact with the motor inductance of the stator, the wave will be like this. Why VF ratio? VFD means you can change the speed of the motor by changing the frequency. There is no role of voltage in regulating the speed of the motor, but voltage will have to be need to be reduced when frequency is reduced. Why it is so? This is the coil formula where induced EMF is 4.445 FT. This is standard formula. If you see, this is flux is equal to E by F. E by F means flux generated in the air gap of the motor is depends on the voltage and frequency and its ratio, V by F. Suppose I want to run the motor at 50% speed. Say 1000 motor, 1000 RPM motor, I want to run it 500 RPM. Then what I will do? I will reduce the frequency 25 hertz and keeping the stator voltage same. What will happen? If you see the rated flux in the motor, if you apply three-phase supply 50 hertz, dual starter or star delta starter, in that case, flux in the motor is 400 divided by 50, that is the ratio of 8. It means flux in the air gap will be maintained constant only if the ratio of V by F is 8. Suppose I want to run the motor at 50% of the speed, means I am reducing it to 25. And if I keep the voltage 400, in that case, flux V by F ratio will be 16. Means your stator, the flux in the stator will be 2 times of the rated current. That 2 times of the rated current, what will happen in that condition? It will generate massive heat in the core, and core insulation will break down. So when we reduce the frequency, we reduce the voltage also. In this case, you can see I am reducing the frequency 50 to 25. Then I will have to reduce the voltage from 400 volt to 200 volt, so that I can maintain the flux in the air gap constant at the rated flux of the motor. This is a three-phase full wave bridge rectifier. First section of the VFD is the converter section. Converter section, you know, three-phase is fed to 6 bridges, 6 diodes, and conduction is according to natural conduction, phase-to-phase voltage. It is conducted. You can see in one cycle there will be 6 pulses of like this. 6 pulses means 6 times it will be there. DC, you need to remember this. When three-phase supply is fed to three-phase full wave bridge rectifier, then its output DC will be 1.35 times of the line-to-line voltage, PLL, or VRMS. PLL is the RMS voltage. So suppose 400 voltage, your RMS value you are giving at the input, then DC voltage will be about 1.35 times of the 400. It will be around 650. This is 12 pulse series converter. It was 6 pulse inverter circuit, and this is 12 pulse BFD, 12 pulse series connected bridge converter. Why 12 pulse series converter is used? 6 pulse can also run the motor from 0 to base speed. 12 pulse can also run from 0 to base speed. Then what is the need of 12 pulse? Here I would like to share something about harmonics. In case of VFD generates harmonics. And harmonics is nothing but the power frequency other than fundamental frequency of 50 Hz. Suppose 100 Hz frequency, then that is harmonics. 150 Hz, that is harmonics. 200 is harmonics. So 100 Hz is 2 times of the 50 Hz, means this is even harmonics. And 150 is 3 times of fundamental, that is odd harmonics. If you see the inverter output, the output waveform is symmetrical about the x-axis. according to Fourier series, if any waveform symmetrical about the x-axis is positive and negative, shape is equal, in that condition, the second order harmonics will be zero. So therefore, we are concerned about, because it is the inverter output waveform is also symmetrical about x-axis. So we are also concerned about the even harmonics, odd harmonics, like 150 hertz is the odd harmonics, 250 hertz odd harmonics, 350 hertz odd harmonics. So even harmonics gets eliminated as per the waveform symmetry. So if you are using 6 pulse converter, then what type of harmonics will be generated? The harmonics generated in the system is pk plus minus 1. K is the integer. For example, for 6 pulse, p is the number of pulse. In this condition, 6 plus minus 1 is 5th and 7. And next you put 6 into 2 plus minus 1, 11, 13, 5, 7, 11, 13. Okay. Second, the magnitude of the harmonics current is equal to the fundamental current divided by the harmonic order. Suppose 5th order harmonics, what is its magnitude? Suppose fundamental current is 100 ampere, then 100 by 5, 20 ampere will be 5th order harmonics. Its magnitude is very high. So here need of 12 pulse series converter comes. In 12 pulse series converter, the lower order harmonics 5, 5th and 7, which is predominant in the magnitude, is eliminated. Why? 15 plus minus 1. It will generate starting harmonics 11 and 13. So in that condition, 5th and 7th harmonic order will not present. So this is 12 pulse configuration is used. As number of pulses increase, you can use 18 pulse, then that 11, 13 will also get eliminated. In 12 pulse series converter, one transformer used. Its vector group is DD0, DD011, DD0Y11, 0011. Here 2 bridge is used. In 6 pulse 1 bridge is used, and this is because of this region 2 transformer. If you add the current of these 2 transformer, 5th and 7th order harmonics will get eliminated. Current in star winding, you can see minus 1 by 5 cos 5 omega t. This is the 5th order. Plus 1 by 7 cos 7 omega t. Current in delta is plus 1 by 5 minus 1 by 7. If you add net current means star winding and delta winding, summation of this. If you sum up both current, you will, this 5th order and 7th order harmonics will get nullified. So lowest order harmonics present in the 12 pulse configuration will be 11 and 13. Again, I explained harmonics pk plus minus 1. In 12 pulse, 12 into 1 plus minus 1, 11, 13, then 23, 25. Second, these harmonics also disturb the motor tone. Motor tone is harmonic number. If we see 1, 2, 3, 4, 5, 6, phase sequence, positive phase sequence, fundamental component. If we are feeding the phase sequence R by B, or current is in phase of voltage, that will create a positive torque, or phase sequence will be plus. Second is the minus. If it is R by B or Y by R, if phase sequence is reverse, it will generate negative sequence. And third is zero harmonics. So when second order harmonic, the second order torque or phase sequence is present, then the net torque will reduce. In case of, if you are not using VFD, you are simply running the motor with the star delta starter, and on after that completion of the delta timing, it is running at full speed. Even in this case, if your rotor one lead gets open, what will happen? The motor will draw unbalanced current. Unbalanced current means that current can be resolved into two components. One is the positive sequence, one is negative sequence. That negative sequence component will reduce the positive sequence component torque, and thus net torque will increase. That's why motor will draw more current. One more feature in DC bus capacitor pre-charge circuit, large rating electrolytic power, this electrolytic capacitor used for filtering purpose. In that condition, what will happen? If we switch on the rectifier, this capacitor will draw very large current, because when you charge any capacitor, it draw very high inrush current. To limit it, in series, some choke or resistance is used, and after some time, that is bypassed. This is the pre-charging of the capacitor. This is 6-step VSI. There are two technology, inverter and current source inverter. Voltage source inverter is widely used in industry. Current, it has many advantages over the CSI. This is 3-phase voltage source inverter, 6 IGBT in each phase. This is the DC bus voltage. Then DC is again converted into AC voltage by PWM inverter, pulse width modulated inverter. To convert DC signal into AC signal, the controller issue the start command or start pulse to the individual IGBT, so that 3-phase can be generated. This is the sequence. S1, S2, there are 6 switch. You can say 6 IGBT is equal to 6 switch. Switch number, this voltage up to 180 degree, the sequence will be this. After 180 degree, this sequence. So output will be again AC. Why pulse width modulation is used? As we discussed, to maintain the constant flux in the air gap, voltage ratio of VF required to be maintained constant. It should be constant. To maintain the V by F ratio constant, we use pulse width modulation technology. In pulse width modulation, carrier wave frequency, that is the carrier wave frequency is superimposed. Modulating signal is the frequency which you want to feed to motor. Suppose I want to run the motor at 40 Hertz, then the sinusoidal 40 Hertz is superimposed on the carrier frequency. Carrier frequency may be in the order of 2 kilohertz to 15 kilohertz or more. So when this is superimposed on this, then this is the point where you will get a pulse. This is the point when crossing point. At every crossing point, we will get the point. You can see the width of the pulse is varying. Frequency will be equal to this signal, but the width of the pulse is varying. This, if you take the RMS value of this, voltage will be reduced accordingly. As you increase the frequency, the voltage will, RMS value will increase. If you reduce the frequency, RMS value, its width will be changed. So by changing the width of pulse, the voltage can be controlled. So this way, PWM inverter control the voltage and frequency both, and VF ratio is maintained constant. In some of the application, after reaching at the base speed, by controlling the frequency, we have reached at the base speed. And beyond that point, if I want to run the motor, I guess suppose 1500 RPM motor is, say, if I consider sleep, then say 1460 RPM motor, I want to run it at 1600 RPM. How I can run it? I can run it VFD. From 0 to 50 hertz, we can run the motor with constant torque. Constant torque because you are maintaining in this region up to, suppose it's a 60 hertz motor. 60 hertz motor means it will deliver the constant torque in this region, 0 to its base speed. After base speed, your voltage is, suppose 400 voltage drive, your voltage is 400, frequency is 50. Now I want to increase the speed. Yes, I can increase the speed. By increasing the frequency, what will happen? Flux will reduce because now there is limitation. We have controlled the voltage up to maximum, and now we cannot raise the voltage above 400. Your DC voltage is, input voltage is fixed, so voltage has reached up to its maximum limit. Then in this condition, what will happen? Flux in the air gap will reduce. Flux in the air gap will reduce means the motor is not able to deliver that much torque which was delivering in the operating region. But speed will increase. In that condition, frequency, you are increasing the frequency. So by increasing the frequency, speed is increasing, but motor is not able to deliver that much torque. And in that condition, you can increase the speed. Where we can use some of the loads demand very low torque when it is operate beyond its the rated speed. Rotary kiln. Example is rotary kiln. Once you rotated it, once load is rotated up to full speed, it requires lesser torque. In that condition, we can increase the speed up to 1600 RPM. So there are two modes of operation. One is the constant torque mode. Up to base speed, you can go in the constant torque mode. Then there will be a change in the torque, but it will take the speed is increasing, your flux is decreasing, or torque is decreasing. Torque is decreasing in the same proportion as frequency is increasing. So P is equal to 2 pi nt. N is increasing, T is decreasing. You are running this motor in the constant power mode. That is constant HP mode. There are two modes of operation. Now we will discuss about different braking method, dynamic, DC, regenerative braking. I have already explained about it. In case of regeneration mode, all the power will be sink into that capacitor bank, and then IGBT will switch on, and energy will be dissipated in the regenerative register.
Fine, sir. Yes, sir.
Yeah.
So, yeah. So we'll give last 5 minutes for the question answer session, sir.
Okay. Fine.
So I have some of the questions. Like
we can take question
yeah,
answers. This is last slide.
One of the student, he has asked us, like what is the importance of IGBT in inverter?
Okay, IGBT actually starting in VFD. I can remember in 1992. In 1992, we were using VFD, which used IGBT. Not IGBT were not there at that time. BJT were there. So BJT based VF drive was there of 3.7 kilowatt. In that condition, with use of BJT, there is a drastic voltage drop or switching losses is there. BJT is not used. BJT is not used because of two reasons. One is power dissipation is high. Second is switching speed is low. IGBT is used because its switching speed is very high. We are using the carrier frequency up to 15 kilohertz. Means fast switching is required. For efficiency of inverter increase with increasing the switching frequency. That's why IGBT is used. IGBT is very fast. The switching speed is very fast. It is easy to turn off. But turn on time very less, turn off time very less, switching frequency very fast. There are three reasons why we are using IGBT.
Okay, sir. The second question we have is, what are different types of speed controlling of motor and which one is preferable? What is the reason for that?
For speed control.
Yeah,
For,
speed controlling of motor.
Motor means induction motor or all type of motor.
Like AC motor and DC motor. He has asked, sir, AC motor and DC motor.
Yes. In DC motor, we are using this DC drive, thyristor based DC drive. And in AC drives, in slip ring motor, we can use GRR, grid rotor resistance control. But nowadays, slip ring motor is also obsolete type. Industry is not using slip ring motor. Industry is not using DC motor. Now, squirrel cage induction motor is number one. No one is preferring DC motor or this slip ring induction. Even people are purchasing VFD with squirrel cage induction motor for starting and stopping as a starter. They don't need to control the speed, but they are using it for starting and stopping. So best method of speed control of squirrel cage induction motor is PF drive. PF drive where you can save the power. If you are using the VFD in fan or pump application, you will save the energy drastically.
And another question we have, sir, like how do we get to know about the dynamic braking in the industrial application? Like how can we select? His question is like that.
Yeah.
How can we select dynamic braking?
Dynamic braking is required where some external force starts rotating the motor. Like in our case in cement industry, kiln area, cooler fans. There are series of cooler fans. When 7, 8 fan is running, and when start command is given to ninth fan is already running in opposite direction. Because of these 7 fans already running, because of its pressure it is running. In that condition, we need VFD. VFD with dynamic braking control, DBR.
Okay.
And second, if you are using the VFD in crane, hoist.
And last question.
Yeah.
So the next question is, sir, what is a regenerative braking?
What is regenerative braking? Regeneration means motor starts working as a generator. If slip ring is squirrel cage induction motor is working as a generator, it means its rotor speed is more than the synchronous speed of the motor. It means this rotor is being rotated by some external force. That's why its rotor speed is more. Otherwise, it will be always less than the synchronous speed. In that condition, squirrel cage induction motor will work as a generator, and it will generate the energy and start pumping that energy into DC capacitor. This is rectifier, then capacitor, inverter, and motor. Then from motor to inverter, then to capacitor. All energy will sink in the capacitor, and that capacitor after sinking the energy, the voltage of DC bus will increase. That is sensed and dissipated in the register. And sometimes this is the one case. Secondly, if you don't want to dissipate it in the register, what we can do, a first rectifier section, you use IGBT based rectifier section, and that energy can be again pumped into the mains. That can be fully utilized. If you don't want to waste it, we can take that energy, regenerative energy, into mains again. In that
Yes, sir.
condition, that rectifier will work as a inverter, and that inverter will work as a converter. Function will change.
Yes, sir. So that's all. So the questions are almost over. So I hope this 1 hour session is very, very informative for all the participants also, sir, because you have shared your lot of experience in your slides, which I have seen. And I'd like to thank you from the university end and from our department also. Within a short span, you have agreed us to give your expert lecture on this VFD topic. Thanks a lot, sir.
Thanks a lot. Thank you, sir.
Thank you, sir. Hello. So, sir, hello, sir. Hello. So the session is over. Expert has left the session, sir.